to the 5th installment of the Air Acuity webinar series. We're trying to bring unique perspective to HVAC design and future work. I am working from New York City to Buffalo up to Maine. And I just wanted to thank everybody for joining us and hope everybody's safe. So we have a great panelist today and really excited for the discussion. But before I get to our speaker, I just want to give some background and context on how we came to meet. So for those that don't know, Air Acuity is an air quality monitoring platform used to measure and control building ventilation systems. We are celebrating our 20th year measuring IEQ in over 100 million square feet across 17 countries. Our company DNA is critical environments, so basically lab buildings. However, over the past years, we have expanded to K through 12 facilities, parking garages, public assembly, sports arenas, and of course, commercial office, as the importance of air quality to human health has become. That leads me to today's panelist. As we expanded to working with commercial customers, we consistently ran into a new air quality standard, reset, which was gaining traction globally with the highest adoption in Asia. So we had to get to know who was behind the standard that all our customers were pursuing. So our panelist today is Reset's founder and CEO, Rafer Wallace. An architect by training, Rafer is a green building pioneer in China, and his passion is figuring out how to use data and standardization to accelerate healthy building adoption. We believe strongly in Reset's mission of continuous monitoring, benchmarking, and communication of air quality data. So Rafer has lectured around the world and been featured in the New York Times, the Wall Street Journal, CNN, and he's even given a TED Talk. So we are very excited to have Rafer speak. He brings a global perspective to COVID and IEQ in buildings. And further, as China is ahead of the US in terms of reopening, Rafer can shed some light on what's to come. So with that, I'll turn it over to Rafer, where it's midnight in Shanghai. So it's all yours, Rafer.
Thank you very much, Walt. And I hope you can hear me okay. The line was cutting in and out a little bit. So if I do cut out on my hand, give me a hand signal or something. And thanks everyone for attending. It is midnight here, and for better or for worse, that is the new reality. And I will use that as a caveat in case I say anything slightly strange. I'll blame it on it being midnight. What I'm going to do here is really give a candid digest of our past 15 years on this topic. And I want to thank Walt and team. I've had the pleasure of meeting a lot of the Air Acuity team live in New York or in Shanghai. We've had the pleasure to cross over on some amazing conversations. There are very few veterans in this space who've been around as long, so that's been really great. I'm really happy to be able to have this chat. And as a result, sort of really, again, going to be keeping this quite rapid fire, despite it being midnight, and candid. And I will keep this open as well, if you don't mind, just to make sure the screen, well, actually, let me try, see what happens here. Okay, that doesn't look so bad. All right. So diving in quickly, this is what we're going to be plowing through. Some key lessons mainly as the body of this, and ending on some of the work that we're doing today. So for some of you who may be familiar with our work, some of this might be a little bit what you've seen before. Again, I am covering past 15 years, so there's a little bit of history there. But before I jump into exactly who we are, I'm going to jump into start with a slightly overused new normal, which for a lot of us in the field is really a bit of a misnomer, because what this is very much about is the old normal without the veneer, without the filters. We've had to deal with at least 5 health crises in the past 18 years. Most of them, some of them national, some of them Asia-wide. This is the first global one. But once you get past 3 or 4 health crises, and certainly nothing worth bragging about there, but there are patterns and lessons that start to settle in, and aiming to share some of those tonight. And I'm not going to go through all of them, but I do want to just look at a couple of them in context. Probably the most significant one after SARS is the 2013 apocalypse, which most of you are familiar with, but it's really just taking a moment to understand the implications of this one. So when this hit, it was a new problem with the feeling that people couldn't escape, and a real sense of panic that settled in. And for those of us who had been tracking the air quality data for years, we realized that this actually wasn't a new problem. This was an annual problem. What we were seeing was an acute condition of that annual problem. And the only thing that was really new was the awareness. And we had data going back to 2005 that was showing PM10 completely off the charts. So really not a new problem.
Hey, Raythier, your slides need to, I think you need to start your slideshow, sorry.
Are they not moving forward?
Yeah, they're not. There you go. Yeah, we can see the slides down the left-hand side, but I can see the 2013.
Can you see the main?
Yeah, we see the main slide, but it's I think play slideshow or maybe start slideshow.
If I was sorry, thanks Dan. I was just on play and it seems like that was not working. So maybe I keep it expanded like this.
Yeah. We're following it now. So however it works for you. Thanks.
All right, many thanks for the heads up there. So this is the slide you should have been seeing on the new problem, can't escape, sense of panic. This is an old graph from 2007, 2005, when we first started tracking this data, showing that it was not a new problem. And generally the panic that settled in, where this realization that outdoor is deadly, you don't want to take your kids out, you don't want to be outside. And then as you start tracking data, that realizing that indoor is worse. So where do you go? A real sense of panic. Deaths outdoor, just to put this in proportion, today, as most of you know, have climbed to about 3 million annual deaths a year. And when we put that in the built environment context, we're at about 8 million deaths a year. So just a reminder that these are extremely severe and extremely significant numbers, which for most people came to light with, again, this quote unquote new problem back in 2013. And the big question was, is it possible to take the death trap that buildings consist of and turn them into safe havens? And of course, over the past many years, the answer to that has been yes. Now we shift gears to today and we look at the 2020 SARS-CoV-2. Similar reaction, it's a new problem. Feeling of not being able to escape. Doesn't matter where we go in the world, can't escape this. And without question, a sense of panic that's settled in globally. Again, for those who track, this is not a new problem. It's an old problem. We're just seeing an acute condition of it, having leapt over international boundaries. And it's really the awareness that is more new than anything. But we're asking the same questions all over again. Buildings are considered death traps. Is it possible to make buildings safe havens? And we believe the answer to that is an obvious, or maybe not so obvious, yes. And so in these 5 crises over the past 18 years, what we've learned is crises come and go. The key difference is really on how they're managed. Meanwhile, the buildings adapt and persist. So from that perspective, we look at what's going to change. And what we realize is that the real estate doesn't actually change that much. We see incremental improvements around infrastructure, mostly things that are invisible, and I'll touch upon some of those. But the thing that changes, and we'll see a quantum leap this time around, is the measurement of risk. So here, this is where we're going to see the real exponential change. And if there's one thing to retain in today's presentation, this is it. So on that note, I'll shift a little bit briefly to who we are. As mentioned in the intro, I stumbled into this field as a byproduct of the work that we were doing on healthy buildings in China, and then have grown out of there very much organically to North America, Asia, and now into India. But we started off as the world's first standard to be tracking the performance of building in continuous time with sensors, either at portfolio scale or at floor plate or office within floor plate scale. And one of the key differences is because it was from the ground up an operational standard, we started looking at data in modular ways with the belief that if you're doing air, for example, you can't pick and choose a few elements. You have to do all of the air. Otherwise, just looking at PM creates obviously issues with carbon dioxide and vice versa. We started tackling these sensor-based issues one by one. You're going to see this page many times throughout the presentation, so a word of warning. But suffice to say at this stage that like other sort of sister standards, we split the way we look at the world in core and shell and interior, but with a very different view on how those two come together. And I'll get back to that in a moment. And the crux of what we've been doing at Reset is really, it is first and foremost a standard for data quality. And that meant, again, this is a bit of an oversimplification, but sort of historic backing here, launching the world's first standard for hardware back in 2014, 2015. And this was based on our 10 years of working with hardware prior to that. Standard for installation and maintenance, and standard for data communications. And I'll get into that a little bit in a moment. And then generally, because we're the only group in the world that's tackling the issue of data quality within the built environment, the Reset standard has dovetailed into most of the standards that you'd recognize. Fitwell, Passive House, Living Building Challenge, of course, lands a whole bunch of points in LEED, so on and so forth. And very briefly, the type of projects that we work on are either new office towers, a lot of building retrofits. That's probably the largest volume of work is on existing building. Interiors, and then that spans across schools, educational, hospitality, and hotels. That's a little bit about who we are. Now, switching over to the fun part, or the more fun part, just pulling out some of the key lessons over the past 15 years. If I look back at a simple diagram on airpocalypse, in 2013, when the airpocalypse hit, there were two monitoring companies at the time available in China that were worth looking at. 18 weeks later, crisis always being an opportunity, there's about 18 companies that suddenly came out of nowhere and hit the market. 18 months after that, most of them had disappeared, gone bankrupt, changed business, whatever, and 4 of them remained. And we've noticed this pattern again and again within crises. A lot of solutions or hardware and things like this appear. Most of them disappear several months after crisis has passed. There's only a few resilient ones that come through. The ones that do come through are typically always the same. They're the ones that are focused on quality, longevity. And this is an old slide, but it's still the best sort of representation of the type of data that we were seeing, where when we started working within this field, the only thing that was available was either the reference grade monitors on the left-hand side, which you typically use in a pharma lab. Many of you are probably very familiar with these. This one's a 6-channel monitor, and you'll see PM 2.5 there, which is very, very faint at 144. Then there was the consumer grade Amazon sort of Taobao toys, which in this case shows that PM is high, but it's off by 40%. That might be good enough for your home or for your car, but it certainly isn't good enough for operating a building. And so what we created was a grade in the middle. And again, we don't build or sell monitors. We set the standard, and then others make the hardware that we then test. So we created this designation for what we needed within the real estate industry was a monitor that we could leave on the wall that could be maintained and could serve for automation that was somewhere between farmer grade and consumer grade. Now, flipping over to, so that set the bones for what we do today on the hardware side, and I'll have a little more to share on that in a moment. Some of the key lessons in software and data, and many of you have maybe heard me go through this before, but there's the software piece is the one piece that virtually no one ever looks at. There's been a common belief in the industry that you can use software to fix bad data. And of course, this is a classic garbage in, garbage out rule. But if the hardware data is bad, there's no way to use the software to fix the data. And looking at the way the data is computed is critical. So within Reset, we provide an open algorithm for how people are averaging data and communicating the data, so that from building to building, the data is actually comparable. Numbers may look the same, but how they were crunched being very different ends up in telling very different stories. Other simple concept is how much data is actually getting through. And I use this particular example of, how many words can I block out in order to understand that this text is still about topic. And similar to how much data needs to be coming through consistently to be able to evaluate the healthiness of a space. And then when we receive it on the Reset side, we're looking at outliers. And so here, some key lessons where minute by minute data is very useful for facility managers, but it's not all that useful for occupants. It can even be a liability. A lot of standards require annual averages, which is completely useless data. Data should not be collated into an average that's more than 30 minutes, and it needs to be evaluated daily to be of use within building evaluation purposes. So just a quick snapshot on software and data, and then some key lessons on installation. And a lot of what we've been seeing in the West right now is really repeating a lot of the mistakes that we were seeing in China and Asia over the past decade or so, where I'm having every day a request after request from landlords and operators specifically, who are asking about how many monitors they should be placing within their tenant spaces. And our response to that is, why on earth would you want to do that? Why would you want to monitor in a space that you can't control? That's like being asked to take care of somebody else's 16-year-old. It's not a good idea. It's a recipe for problems. And so we always encourage landlords, especially, to take a step back and start by monitoring what you can control, and then work from there. And so this is a key way in terms of how the Reset standard is set up. With the core and shell system, where we're tracking air quality, both outdoor and in duct, on the supply before it gets delivered to the tenant. So really helping the building owner communicate and track what it is they control entirely, and defining their responsibility there, versus what the tenant is tracking, providing guidance on how the tenant tracks their own data. And then in this way, helping the two parties actually work together as opposed to antagonistically. Now, key lesson in terms of operations, what this boils down to in terms of results that we're trying to get when we're tracking all of this data from outdoor to supply to indoor is really getting to a sort of dynamically balanced, responsive system for obtaining clean air. And for us, that's meant CO2, PM, RH, temp, VOC, and sterilization. So that package of minimum parameters for the past decade. As I was explaining earlier, the best way that we found to achieve that is really to have a clear delineation in responsibility between what the owner is responsible for and what the tenant is responsible for, and how we bring those together. So, you know, filtration, disinfection at the central level is at the central mechanical level is probably fairly obvious for most filters, MER 15, MER 14 within air handling units, UV sterilization, things like this. What's less familiar is how that flowed over into what we call the state system, sort of the local tenant level, where with an installation of mini BMSs and scrubbers there that actually empower the tenants to have more control over their air quality and remove some of the load from the central system, saving energy in the process. If you've never seen what these look like before, they've now become, we pioneered the first of these units back in 2007, 2008. Now they've become ubiquitous across Asia, but they're really just filtration devices that are bolted to the ceilings and are fully standalone, either stripping out CO2, in some cases CO2, but mostly PM, VOCs, and of course, if HEPA, then going for microbial as well. We spent a lot of time looking at cost effectiveness of this. Again, we're not in the business of selling these things. We're just looking at performance, and eventually figured out that by far the most cost-effective way to get to highest performance within buildings was this mix of central system and mini system working in tandem, getting the highest performance for pretty much the lowest install cost. That's always a kind of a happy situation you want to be in. And then just a concrete example of how that applies, and especially in sort of COVID world. On the reset side, we've been looking at temperature and humidity as health parameters pretty much from the beginning. And most people often thought that was quite strange, seeing as typically those parameters are associated with comfort, not health. But the research is pretty much everyone right now is familiar with, given all the mediatization of this, is direct correlation between viral transmission and humidity. So this is not new. This is research that's been around since the 1960s. It just keeps getting reinforced and people keep rediscovering it. But ideally, as most of you are aware of, keep humidity between 40 and 60%. Rate of viral transmission goes down. And when people, my point here is when people hear this, especially tenants, they'll turn around to the landlord and say, hey, landlord, I saw it all over the New York Times. I saw it wherever. I need more humidity in my space, especially in winter, it's dry. How can you give me more humidity? And this is where we step back and say, look, no, this is not a good idea. You don't want to ask the landlord for more humidity. That means more moisture in the ducts, it leads to mold, has the risk of leading to Legionnaire's disease. This is not a central mechanical solution based, it's a tenant based solution. And so going back to these research type units, these more local units for local management of air quality. This is where this split between how the tenant and the landlord work together based on data becomes really powerful in properly identifying who's responsible for what. Now, just wrapping up with where we are today and bringing this into the context of pretty much what's on most people's mind. re-entry with respect to COVID-19 and how we move on from this. I mean, first, just stating the obvious that infection has always depended on these three things, which somehow are new again. But viral strength, which is the health of the virus, immune system strength, which is something we surprisingly don't speak enough about, but the health of the human being, the health of the host, and then the exposure time. That's it. That defines the risk to infection to anybody indoor or out. And so what we're hearing a lot of in the West right now is very much a healthy building one-liner or two-liner, sort of this constant repetition of ventilate, 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 ventilate as much as you can. Do not recirculate. Recirculation is dangerous, which, to be frank, is fairly medieval advice, and it's good emergency advice. But I'm very disappointed that a lot of our peers are not adding nuance to this and helping building owners look forward to how they should be really operating the buildings moving forward, and how they should be gearing up for beyond ventilation. Because again, pure ventilation, as it's being expounded today, is really fairly medieval in terms of advice. And I'll try to explain some of the caveats that should be mentioned around this, but somehow rarely ever do get mentioned, other than very recently. But this is this particular map you may have seen. It dates back. When did we prepare this? Dates back to early April, I guess, where we're adapting this amazing research that had been done on overlaying temperature, humidity, and within a band around the world, and found that all the major cities that had been hit by coronavirus all magically lay precisely within the same temperature humidity zone. And then when that data was extracted and looked at other cities that would fall precisely within the same specific humidity and temperature zones with time, you know, a few or many of the ones that came to reality were already listed. New York, London, Berlin, Vancouver to some extent, all fell within that band, either weeks or 1 week or several weeks after these initial numbers had been put together. So highlighting the importance of humidity and temperature on viral transmission, but this was outdoor. So the question is, how was this translating to indoors? Because, you know, very few, 0.3% of cases are caught outdoors. And a lot of this had to do with ventilation, over-ventilating. So the ventilation one-liner that's being delivered assumes that a building has the ability to meet heating and cooling loads without recirculation. Well, most buildings don't. And so people have been freezing in buildings or overheating in buildings. That's very much the case that we're seeing globally. But if you're pumping perfect outdoor conditions in, then that does two things. That negatively impacts the immune system. We don't function particularly well at 10 degrees Celsius indoors, and increases the survival rates of viruses. So ventilation, good emergency procedure, but really needs to be caveated based on what are the outdoor conditions, and do I really need to be ventilating that much, depending on how many occupants I have inside. Again, old information that suddenly became new again was PM 2.5 and the effect on immune systems. Again, a lot of this is information that's been known since the early 2000s. And an increasing issue in North America. People used to dismiss this in North America, say this is an Asian problem, but obviously very much a European problem, very much a North American problem, especially with the relaxation of air pollution laws in the US. but really just increasing the perfect storm here. Most buildings in North America, Europe are not equipped with the same type of filtration that you'd find in Asia. So the ventilation one-liner again assumes that ability to meet heating and cooling loads as mentioned, but also assumes that the outdoor air is clean, or that there's the ability to meet filtration needs without recirculation, which in many cases is again very much not the case. So what we end up doing is further negatively impacting immune system and still increasing the survival rates of viruses. So again, kind of stressing one of the key lessons that's come out of the past 15 years of doing this is 100% ventilation is an emergency measure and not a particularly good one. So it should very much be caveated when it is being sort of expounded as it is, especially in North America these days. And the key lesson here is that really ventilation has to be more dynamic than it's ever been before. So healthy buildings are very, very, very much going to be smart buildings. A much more complex relationship, as we've been seeing in Asia, trying to balance PM, VOC, CO2, parameters that tend to go in completely different opposite directions to one another. So here, tracking outdoor conditions, the ability to clean and condition centrally, the number of occupants, and then the ability to clean and condition locally with these scrubbers. So we're going to see more complex smart building systems that are both centrally and locally managed with the need to talk to one another and with a central nervous system that tracks outdoor induct, very, very important, the induct information, as I've been trying to stress, and then finally the indoor information. So expect to see a big jump in smart building systems, obviously, but not just the way we normally imagine them, typically central controlled, but very much decentralized within these tenant spaces. So going back to these three pieces, what does that mean? It means, of course, a lot more tracking of humidity and temperature, not just as we normally do with thermostats within a space, but within central mechanical system. That's to look at viral strength, humidity and temperature, as well as particulate matter. And I guarantee you're going to see it in the headlines very soon, the impact of chemical off-gassing on viral transmission. So those parameters needing to be tracked, and then exposure time tracked via air changes and occupant density. Now, in all of this, sort of key takeaway is the question really should be, is the air clean and safe, as opposed to, is the space ventilated? And as part of the clean and safe, this is what we're currently doing with monitors. We're now working on an advanced standard for monitoring, which tracks broad spectrum monitoring, so PM 0.3 to PM 10, which is the sort of the most prevalent range in terms of airborne droplets that would carry a form of virus. Okay, I'm almost done here. A couple more minutes. Communication in terms of leveraging reset. So obviously a lot of requests and needs for taking this data and making it intelligible to the average user via third party. So this is the type of information that's being communicated within buildings. From a back end, leveraging this type of data in order to, when people are in emergency mode, looking at CO2 rates to show that there's no cross-contamination risk until people do have the confidence to come back to recirculation, looking at immunity suppression risk. Are there buildings in the world that are able to track like this? Yes, of course there are. This is just a snapshot of Shanghai as an example. One of the first buildings that went online in Hong Kong, a couple buildings that are in the works in New York, some fantastic partners in North America. And then finally, a little bit on engagement. So, we're seeing what's one of the key lessons, one more of the key lessons that's been coming out of this is that, in case it hasn't come across clearly enough yet, air quality management is not just a landlord priority. It is also a tenant priority. So putting all of that burden onto the landlord makes no sense. Putting all of it onto the tenant makes no sense. It needs to be a shared piece. And so there's been a bit of a struggle for tenants on how do they engage, for landlords on how do they engage their tenants into this process. And as a byproduct, one of the things that we've been doing a lot with the Asian developers and now are bringing to North America and Europe are these third-party leaderboards that allow for a neutral collection of data so that tenants can see how they perform and how they benchmark against one another anonymously, and can start learning from one another on what's possible within a building. This is what the dashboards actually look like. I can go into detail on that another time. And the type of requests that sort of spin out around this, where people want to socialize this data, want to show their occupants on how the data impacts their personal health. So just making it more approachable. The final bonus here is that as we work through this, we're hitting the dual goal of both meeting new air quality requirements. As awareness goes up, of course, the requirements are going up, but also energy and carbon goals. So again, these are typically goals that are at odds to one another, as most people realize. Added filtration, so on, increases energy goals. You hit cities like New York that are already up against the wall in terms of having to reduce energy. So increasing air quality targets is a bit of a nightmare. But the process of engaging the tenants on these performance leaderboards, these third-party performance leaderboards, is where we're seeing the largest opportunity to unlock energy savings while helping meet these energy targets. So this is my last slide. Hope that wasn't too rambling. Past 15 years of some key elements, some of the key lessons. This is usually about a 3-hour piece summarized in 35 minutes. And the key takeaway is it's never too early to start learning. So choose a project, make it a pilot. There's a lot to learn. And on that, I will end here and turn it back to you, Walt.
Walt, are you there? This is Dave. Okay, there you go.
I see a little mute icon on the phone.
All right, can everybody hear? Can you hear me now, Rafer?
Yes.
Great. I guess, yeah, one of the questions I think would be great just to cover for a second, because you are located in Shanghai, is just you did mention that many people are back to work today, and I know this is probably a loaded question, but can you give us like some insight on what's, typical office space, kind of what that looks like? Has anything changed? And what can we expect here in North America?
Yeah, I mean, we've been back in the office about 50% starting end of February, and 100% just a few weeks after that. As most of people have seen in the news, Asia, or China particularly, is pretty much somewhere between 75% and 90% normal. What that means entering buildings is of course the thermal checks, and a little more posting in terms of signage on when's the last time the elevator was disinfected and so on. But already when you slip into a meeting, into your destination, nobody's wearing masks. Meetings are fairly back to where they were before. And again, having gone through 5 crises, humans are generally very short-sighted, and we tend to go from one end of the pendulum to the other. And so these very broad statements on everyone working from home forever, how dramatically the office space is going to change, are very, very, very much overblown. Human patterns don't change that radically. And I think China is a very, very good example of that. On, other than some infrastructural changes, more sensors that are sort of slowly being more elegantly integrated into buildings. So not as clumsy as thermal sensors that are stuck in your face when you walk in. Other than those pieces, again, more infrastructure focused. I think people can expect to go back to pretty closely what they knew before COVID.
Right. That's great. And we got a bunch of questions coming in. One question was for kind of DOAS systems that are more typical in the UK and Europe that are not recirculating, more with a DOAS unit and fan coil units in the space. What would your recommendations be for increasing air quality and mitigating COVID transmission in that context?
Yeah, that's a great question. I mean, we just finished a tower in Frankfurt, which is exactly that, 100% delivery, no recirculation. And I'll be honest, I mean, we're still waiting on the data to start coming in on that. So unfortunately, that's not the segment I have the most experience in. Most of them are recirculation in some form or another. But it's really intuitively, it's going to come down to generally people are talking about more volume being delivered, more air changes per hour, and that's could be a good thing, but it runs up again as I was saying, against the ability for the building to actually push that much air through to heat and cool, and then filter that much air. So my recommendation really is to start with the data, and that's we've worked on a ton of existing buildings where people design what they think is a solution, put it in, and then look for results. And typically have to spend quite a bit of money to readjust. I'd really recommend put in the sensors first, capture the data outdoor, pre-filtration, post-filtration indoor, and then adjust the system based on that. And you might find that allows for some tinkering as well. Either some electrostatic to increase primary filtration, mixed with UV, so that you're still getting good air movement within the building without having to go to hospital levels, and without overstressing the building either. So apologies, a bit of a vague answer, but I would definitely recommend starting with the data.
Right. I think that your slide, is the air clean and safe versus how much? I mean, we kind of sing that same tune. You can't manage what you don't measure, and that kind of ties into the next question, which is for older buildings. Do you recommend, not doing anything or keeping the existing systems in place versus increasing outdoor air? And I would imagine your answer would be similar. Is it got to start with the data?
Yeah, older buildings are actually my favorite because they're the biggest challenge. And in many cases, it's older buildings we've so often been in where there's just no capacity to increase air volume. The fan is running near maximum, or increasing fan speed would just destroy acoustics, so create far too much noise. And so, you know, classic things like replacing those with a fan grid, and now there's IoT-based fan grids. So there's been sort of a lot more opportunity in existing buildings to make interventions than we originally would have guessed 6 years ago. And typically, that's also where the biggest wins have been in achieving better air quality at actually a lower energy footprint. But you're right, Walt, I can't stress it enough, starting with the data. And I need to be careful because I could go on for hours about this, but, you know, typical other things that we found, because we tend to work with tall buildings, the difference between particulate matter, temperature, humidity on the 22nd floor or the 56th floor is radically different from what's going on the ground floor. But the average mechanical engineer will specify the same filter top to bottom, which obviously is unnecessary. And so, you know, we've seen buildings apply for reset that follow process. They start with the monitoring and discover that the filtration, of course, top to bottom, has to be different, and specify different levels of filtration at different heights, which reduces energy consumption and increases overall performance. You can't figure any of that out without the data.
Right. So I guess if I was going to just add to that question is, I think it's not leaving systems alone, but it's understanding what the existing system is, and then, you know, taking educated steps once you understand and can diagnose the problem appropriately. So we should do things. We just need to know what to do.
Right.
There's a question. I think one thing you mentioned that I think is maybe a little bit new to many of the folks on the call are about the kind of the tenant level retrofits that can be done, or tenant level equipment that can be done for cleaning, for you know, improving air quality. So I think could you just speak a little bit more about what type of equipment that is, and maybe as a follow-up, or when we share the slide deck, just provide some examples of what that looks like?
Sure. I mean, when we started sort of struggling with these issues back in 2006, 2007, I guess it was looking at how we got filtration units off the ground, because we were getting an incredible amount of turbulence off of filtration units that were sitting on the floor and not circulating air effectively, or in doing so in short change cycles. And what I'm showing in the picture here is really what's become ubiquitous. There are now dozens of companies that make these things in some shape or form in Asia. And they become very, very adaptable. So they're, as mentioned, they typically take a night to install, bolted to a ceiling, are not connected to outdoors, and are designed to power up and down and strip out whatever needs to be stripped out. And of course, in many cases, it's PM and VOCs, but as mentioned, it can also be microbial. And this has been the lessons that have come out of these simple devices, which are now obviously all automated. They're all mini BMS style, have been fascinating, because, you know, I've got a million other graphs, which I'm sure I could entertain you at length with, about, you know, for example, what happens when buildings depressurize at night, when they go from being positively pressurized to negatively pressurized, just by nature of shutting down every evening. And for the people who are still in those buildings, well, when they go into negative pressurization, they suck in all of the outdoor air in. Pollutants, temperature, humidity, everything that's outside just gets pulled in within 1 or 2 hours. And so a lot of the debates that sort of the advanced property owners that we work with then get into is like, well, should we run our mechanical systems an hour longer? Should we run them on the weekends to protect occupants? That's hugely expensive for a handful of occupants. What do we do? A lot of head scratching there. And so what we've seen the most advanced developers do is now start to actually downsize their central systems and provide provisions for these mini BMS type systems that can, they work in tandem during the day. So if there's a surge in outdoor particulate matter, if there's a surge of users coming to the space, so example, high occupancy and you have these things equipped with HEPA filters, well, they'd power up. They'd increase local recirculation without risk of cross-contamination and help the central system manage the surge. And then also, once the central system shuts down at night or shuts down over the weekend, they take over the job of highly localized IEQ management for the few occupants that are left, sort of achieving then these levels at much, much lower energy cost. So what started out as a very, very simple idea is now what we're seeing really changing the way mechanical engineers are thinking about how to deliver these levels within buildings.
Thank you. That's great. And there's a question about humidification. I think just to go back to that topic, I think this has been a big topic that we've maybe learning for the first time or relearning, as you said, about what the appropriate levels of relative humidity are and who should be responsible for them. So the question is it a best practice for the landlord and the supply side to be responsible for humidity, or should that be on the tenant?
Yeah, that goes back to my earlier point. There's a lot of tension, and quite frankly, I mean, Americans are very, very liability adverse, but I see so many liability cases in the making in the US right now. It's scary, where landlords are meddling around in tenant spaces, and tenants are trying to meddle around in landlord spaces, and that's a recipe for disaster. I mean, a story for another night. Reset Corn Shell was born out of a liability case. It was designed to help building owners avoid liability. And so this is a topic we're very, very familiar with. But as I was mentioning earlier, having the landlord go and monitor within the tenant space is setting themselves up for liability. On the reversed side, to answer the question, having the tenant lean on the landlord to provide more humidification is also not guaranteed, but definitely sort of raising the risk for both parties. As I mentioned before, we have seen some very poorly educated, very poorly deployed cases of people trying to do that, but and it's a tough one to manage in the central system because, as mentioned, it increases humidity within the ducts, and so you do get higher risk of mold and Legionnaire's disease and so on. And then the finger pointing starts. And so, I mean, for us, it's been very, very clear that the humidity, long answer to the question, that the humidity conundrum is really best served, is best solved at the tenant level. You actually want the building owner to be delivering dry air. If those particulates are airborne and they get pulled into the return system, then the dry air within the return system has the highest chance of killing those viruses. From our experience, last thing you want is high humidity within central mechanical systems. So that, again, super long answer to the question, but really needs to be handled at the tenant level, tenant responsibility.
Right. I think it goes back to your previous point about this kind of local HVAC system design being more modular and enabling tenants to take action on their side. So, back to your previous point about the scrubbers in space, it seems like there is a push to more modular system design, which this would also apply.
Very, very much so, yeah. But what sort of, but then sharing of data across the systems, which becomes critical. So the building owner measuring and controlling their own data, but being able to share that to the tenants to better operate their systems, and vice versa. And this is a new dynamic we've been seeing, where as we work with tenants within these leaderboards and have been asking the tenants and working with the tenants on how they share the data with the building owner, generally we found a surprising willingness for the tenants to share their data with the building owner, as long as it's anonymous and as long as they get data back. This is also very much disrupting how data is shared via a building for better operations.
Right. And then, Ray, for just the last question as we wrap up, how do people work with you? So if they want to deploy Reset in their building, if they want to understand what this costs to do, how do they find you and start to work with you all?
That's a great question. Thanks for asking. We work very much through accredited professionals, sort of like the sister and sort of partner organizations that we work with. So we have about 500 or so Reset accredited professionals around the world, which is what allows us to be pretty much in any geography. I will be very, very honest in terms of the people who make the best, and it's not a plug, but the people who make the best accredited professionals are typically solution providers. Because Reset, unlike other building standards, tends to require a deeper technical know-how on how buildings actually operate. So networks, mechanical systems, and so on. So our best APs far and wide are those that are solution providers. So you can reach out to me, and I'll happily connect you with accredited professionals they're all independent, very much like lead APs or well APs that are within your geography and within a particular skill set. But obviously, I'd be remiss to mention that Acuity can definitely get you off the ground and well engaged. Walt, I cut you off. Did we lose sound?
Yeah, we may have lost Walt temporarily, but
Okay.
yeah, thank you very much for presenting today. It was all very interesting, and we're going to be sharing the presentation, as long as you don't mind, with the attendees here, so they can check out the slides again and rewatch the presentation for any material, or feel free to share it with others as well. And Dan, do you have any oh, we lost him too. But so we appreciate your time, and we will be sharing everything with attendees.
Fab. Thanks for having me. And thanks everyone for listening.
Thank you, and thank you everyone for attending.
All right, take care now.